Dart Skill presents Gradient of Straight Line. The slope or the gradient of a straight line on the xy coordinate plane is a measure of its steepness. Imagine climbing up a hill. As the hill becomes steeper and steeper, we say the slope or the gradient of the hill becomes larger and larger. For a straight line in the xy coordinate plane, the slope is defined as the ratio of the increase in y coordinates to that in x coordinates between any 2 points on the straight line. So if you have the x and the y axis, here's the x and here's the y axis. Think of a straight line or a line segment and pick any 2 points on that line segment. Let's say the coordinates of this point is x1 comma y1 and the coordinates of this point is x2 comma y2. And if you go ahead and complete the right triangle over here, so this is a right angle, meaning this side is parallel to the y-axis and this side is parallel to the x-axis. The slope is defined as the increase in y, also called the vertical increase, vertical increase, and it's also got a name. It's also called the rise. So it's rising. Increase in y means it's rising. Divided by, so it's a ratio, and the top number is the increase in y or the vertical increase of the rise between any 2 points on the straight line over the increase in x, also called the horizontal increase, or the run. So the slope is rise over run or the vertical increase over the horizontal increase, and that is equal to, for these 2 points, the increase in the y value between these 2 points is y2, the y value of this point, y2, minus the y value of this point, which is y1, over the ratio, it's a ratio of the increase in the y coordinates, so this is y2 minus y1, to that means the increase in x coordinates. Now if you look at this point and this point, the x coordinates, just like the y coordinates, let me just go ahead and draw a dotted line so that you could understand the increase. So if you think about the increase in the x coordinates between these 2 points, this is a x2 and this is a x1. So this is going to be a x2 minus x1, just like it was a y2 over here for this point and a y1 over here. Reason why we had a y2 minus y1 on the top. So this is x2 minus x1. So given the coordinates of 2 points on a straight line, you can find the slope or the gradient of the straight line by using this formula. A few questions to answer though. What is the slope of a straight line that goes the other way? Like this. Now if you pick any 2 points on the straight line, doesn't matter which 2 points, I'm going to pick this one and let's say this one. And if I imagine this to be a hill and this is where I'm standing going this way, I can see that as x increases, so I'm moving in the positive x direction, the value of y decreases. So when this increases, this decreases. And when this increases, when y increases, I'm moving in the negative x direction, which means x is decreasing. Therefore, the slope of this straight line is negative. Slope is negative. What's the slope of a straight line that is parallel to the x-axis? Hey, this is not even a hill, this is a plain land, therefore the slope is 0. And if you want to apply the slope formula, you'll see that if you pick any 2 points, no matter again which 2 points you pick, the y values of 2 points on any straight line that's parallel to the x-axis is always the same. Therefore, y2 minus y1, the numerator, this fraction, becomes equal to 0. So no matter which x's you pick, whatever x2 minus x1 is, this is always going to be 0. So the slope is 0. Now, what happens to the slope of a straight line that is parallel to the y-axis this time? Something that goes like this. Either this side or even the y-axis, doesn't matter. Now if you want to apply this formula out here, the problem is between any 2 points on this straight line that is running parallel to the y-axis, the x coordinates are the same. Therefore, essentially, the denominator of this fraction becomes equal to 0. So the slope is not defined. Slope is undefined. Let's try and find the gradient at the slope of this particular straight line. And to be able to do that, I'm going to choose 2 points of my convenience on this straight line. So I'm going to choose this point. And as you can see, the coordinates of this point is x is equal to 1 and y is equal to 4. So my first point is, let me name that point as P, 1, 4. And then my next point could be this one. I'm going to call this Q. And the x coordinate of Q is 5. So we have a 5, comma, and the y coordinate is 6. And we know the slope of the gradient formula is y2 minus y1 over x2 minus x1. I can choose any of the 2 points to be x2 and y2. The other one becomes x1 and y1. I'm going to say P is my point 1 and Q is my point 2. And therefore, I have y2, which is 6, minus y1, which is 4, over x2, which is 5, minus x1, which is 1. And that gives me 6 minus 4 is 2 on the top, 5 minus 1 is 4 on the bottom, 2 over 4, which is 1/2, or 0.5. So we would go on to say that the slope of this particular straight line, the slope is equal to 1/2 or 0.5. Let's try another one. Let's try and find out the slope of this straight line. Once again, I'm going to choose 2 points, and my 2 points in this case are going to be this point out here that seems to have pretty good coordinates. Good in the sense integer coordinates, not fractional like this one. It's hard to find out the coordinate of this particular point. So I'm going to go with this, as it looks like a -1 on the x and a 7 on the y. So this is my first one. I'm going to call that P again. I have -1, 7. And my second point could be this point, where the straight line actually meets the y-axis. And I am going to say this is my Q, my second point. The x coordinate of this point obviously is 0. It's a point on the y-axis, comma, the y coordinate is 4. Let's apply the slope formula. Slope is equal to y2 minus y1 over x2 minus x1. And this is going to be equal to y2 is 4 minus y1 is 7 over x2 is 0 minus x1 is -1. We need to be careful about the sign because x1 itself is a negative number. So minus -1 minus x1. And this turns out to be equal to 4 minus 7 is -3. And on the bottom we have 0 minus -1, which is 0 plus 1 or 1. And therefore the slope of this straight line is -3, because this line is going down as you move from the negative to the positive direction of the x-axis. And that explains this negative sign out here.